A common task when setting up your applications is figuring out how you're going to route between screens. And in Fulcro, this is probably the most important topic to know about when it comes to performance, because it's a data-driven architecture, and overquerying is your worst enemy. So the basic idea is if you were to put everything in, well, let me just cover it. So let's start with a couple of pages where we just have some really simple code so we can follow this. We've got a home page which says index page. We've got screen 2 which says alternative screen. We've got a report and summary which we'll cover in later bits. So let's just talk about switching between two kind of top level screens where there might be huge recursive queries here. Right now we're only asking for the screen property, which gives us the ID of the screen, and then rendering. So we could use DOM switching, and so to use DOM switching, this is roughly what it would look like. We'd have some sort of root. The query would query for some property, which is only used by root itself to keep track of which page it's on, and then it would do the subquery for each screen. So you can imagine as your application grows, this doesn't scale. Because every time you'd render root, you'd requery every screen, even though the screens weren't actually visible. This does work though, and here's a card running this particular case. When I run the home or the alternate button here, I transact this DOM goto, and all the DOM goto does is switch the current root current page property. So you can see, it's just flipping that one property at the top there, and everything else is static data structured within the component, and we get a potentially large query out of that. So this doesn't scale as your application grows, but for really simple small things, really all we're doing here is a case statement and then either rendering whichever screen. So this also has the potential disadvantage of unmounting and mounting an entire thing. Well, although you're probably going to end up with that no matter what you do. So React will take care of dealing with the UI update. So this one's the easiest to understand and is very often what people do out of the gate because it's really trivial to write. But as I said, that ends up throwing everything in your application that could ever be displayed into the query. So as the application grows, the query gets slower and slower and slower until you're typing into a form and it's like, one frame every 2 seconds. So this is obviously not what you want if you're building something non-trivial. So the answer to this, the simple answer, is unions. So we talked about union queries in an earlier video, and essentially what they're for is swapping queries out based on an ident. So we have the same screens here, and what we've done is we've created a route union where the query is either, if the ident's first element is home page, it's the query of home page. If the ident joining this thing through is screen 2, then the query is screen 2. We still end up with a case statement here to render whichever is correct, but now the screens coming out of the props, which is why our original screens up here, have to record which screen they are. Right? We have to have a way of being able to tell them apart. You don't have to actually embed a property in them. If you can look at the properties and figure out what it is, that's good enough. But you need something here to switch between the two. And so for the routing case, we'll have a union query, the initial state of the first thing, or the default thing, so to speak. And you see this when we go back and we look at this card. Get the state showing there. You see that the root router, which is right here, we get root router goes straight to the union. When that normalizes, we get home page single because the ident function of this union looks for the screen as the first thing, which is going to be home page because we initialized it to home page, and then either the ID, if it has one, and in this case it doesn't, or just the keyword single. So home page, there's a single home page, and there's its attribute values. And so this looks very similar if you compare these side by side, right? This one is swapping a property out that's held by root, whereas this one's swapping an ident out that's causing the union query or the union component. So the actual DOM switching is no more efficient. However, the query that runs against this second version will only query down the route you're on. So you'll only get the index pages query from here because it'll join up the query on the route union. We'll see that in this particular case, home page is the first element of this ident. That's always how unions are resolved. Unions look at the first element of the ident that they're resolving to in the app state database normalization in the graph to figure out which query, subquery gets run. So that's where the efficiency comes from. So it's not a whole lot more to write, right? We can compare them here. Right, with DOM switching, we still have to write in the queries. We just write them into one vector of a query, whereas in a union, we write them as a union query. Notice we have to query for actually less, right? There's not an additional current page property that just kind of disappears. So actually our manual union routing is a little lighter on state. You can see that here clearly. So that's kind of nice, and we're not throwing a bunch of extra stuff in root that we don't even need, right? Here we were joining in all of the screens into root, and here we're only joining the router into root, and then everything else is normalized. So this is lighter in several ways. It does, however, require that you add in that extra component overall. Okay, now this is all fine and good, but this basically means you've got, when you write the mutation, you're manually overwriting an ident in app state in order to route. And this doesn't scale in a different way in that if you wanted multiple routers in your application, you're kind of having to do one-offs for each one, and you can't write a mutation that applies to a specific router. So what we'd like to do is normalize our routers, right? Actually have routers be a standalone component that we can target mutations at and say, I want that router to move to that page, or that router to move to this sub page, etc. We might want to create a tree of routers. And so that's what this looks like. So if we wrap the union itself, which we're still using the same union component up here, we're not changing that. Instead, what we're doing is we're adding in router as a first class component that just keeps track of the current route. And we can also give this router an ID that we pass in from initial state, and then normalize these routers into a router by ID table. So if we look at what that looks like, so this is a manually built router component, we're going to end up with a router by ID called myRouter, and the current route is where our ident is going to be stored. So if you compare those side by side, not sure why those are failing to initialize when I move around on this page, but anyway, here's the manual union, right? I'm changing an ident through my mutation, and here's the router component where I'm changing the same kind of ident but inside of a router component so I can target the mutation. So this is just a slight improvement that allows us to kind of use the same kind of router over and over again based on its ID. So set route now can take the ID of a router and which screen we want to go to, and now I can basically do a reusable thing here. And so now I can call set route, tell it which router I want to change and which subscreen in that router I want to go to, and I've got something that is yet again a little better. But now hopefully you'll have noticed, all right, well we've gone from DOM with querying everything to union fixes our query problem, but we have this like monolithic router for a specific concern that we hand write each time, and that can be okay. It's not that hard to write. We could move that off to a router component where the router has ID, and now we can make a single mutation that can perhaps talk to different routers and route. But we still have the problem that the router itself is tied to this specific union component, right? So we manually wrote this route union up here to join together our various screens and renderers. And so the manual writing of this is a task you're going to do over and over and over again, depending on how many routers your particular UI needs. We've got the control component, but now what we'd like is something that can build the intermediate pieces for us. And that's what Defrouter is about. So this is the central component, pre-built router. Sorry, I put it in a different file. Or did I? Ah, yes, top router. Okay, so here we're still using the screens. Right, so this was our control component where we had set route, where we could set, using a router's ID, which screen we want to go to, made that a reusable mutation. And down here, this macro, which comes from the routing namespace, I'll show you that in the requires up here. So Defrouter comes from Fulcro client routing. This is a built-in Fulcro macro. You can give it the component name of the router. You give it the ID of the router. This is an older macro, so it uses a non-optimal syntax, but I've yet to update this macro to use maybe something a little more consistent with defsc. It looks a little bit more like defui. And so you give it an ident function that takes two parameters, the component class, which you really don't need, and the props, and derives the correct ident for any one of these based on the data in props. So if you remember, on both homepage and screen, we jump to those and look, they have a screen value in both their query and their initial state that names which thing they are. So we can tell this ident function, you need to put the screen from props in the first element of the ident. That's what tells the union how to work. And of course that value needs to match what goes in the union query. And this is a shorthand notation for both building the union query and building the case statement to do the rendering with factories. So this is basically saying when the first element of this ident is homepage, use a factory on homepage to render the props. When it's screen 2, I'm sorry, and this also builds out, the union query of homepage is the prim get query of homepage, screen 2, prim get query of screen 2, right? So you get a query built out of this, and you get a case statement built out of this that's looking at this first element of, or this, I'm sorry, the screen property coming in on props, essentially the first element of the ident. So this builds both the union component and the routing component we saw in the prior examples. So pop back. Remember, we have for I don't know why the inspect data is not showing up without a reload. Remember, we had a route union that we manually wrote, where we had to write both a query, and initial state, and an ident, and then a case statement that did the rendering, along with an invalid route kind of rendering. So this is now built for us. And then we had to build the component that had initial state joined in the router, kept track of what the current route was, and had an ident. So this Defrouter writes both of those. Okay, now let's we're going to worry about routing tree. At the moment, I guess we are going to worry about routing tree because I'm going to show you a little more. So there are various ways of telling this router what to do. For example, there's a set route mutation function where you can talk, not mutation, a function you can compose into your mutations where you can tell a router specifically which thing it should switch to. But more likely what you're interested in doing once you get your routing going is actually routing via HTML5 events, history events, and URL-based interpretation. So I'm going to start with just showing you basically what a routing tree looks like. So in the same routing namespace, the Fulcro client routing, there's a function called routing tree where you can give it various routes. And these routes are meant to be handler names. So this handler name talks about a complete route to some screen in your application, could be nested extremely deep, etc. And then for that route, so for the index route, the instructions that need to be given to various routers, and this is a vector, so each router, there could be 10 router instructions in here telling 10 different routers in your UI system how to switch around to show the specific screen. So telling which router, so top router is the router ID, which thing to show. And so here you give it an ident that this router should switch to. This can be parameterized, and we'll see this in a few minutes. But for the moment, that's what a routing tree looks like. And then in your root, all you have to do is merge that routing tree in with whatever your normal initial state for the root is. So in this case, we're going to put this top router at the root router key. We're going to pull that out of props. Our query is just querying for root router, and then we're placing the routing tree in the initial state. And this is just puts in a routing tree information in a well-known place in your application root. In fact, you can see it when we go to the card here. You can see that the routing tree goes under a namespaced keyword where it's got essentially that data structure that the routing tree built out. So you don't have to know any of the internal details of this. And the rest of this looks very similar to what we had before. Root router points to a normalized router by ID called top router. It has an ID, it has a current route. There's our ident, and you can see that ident's the thing that changes when we move from screen to screen. And then we're using a built-in mutation route to, and route to takes what looks like a biddy match. Of course, you can just manually code it, handler, and then the handler is just the name of which of these routes you'd like to trigger. And triggering that route causes these router instructions to run, any number of them. So that becomes a fairly straightforward thing to build up to get the same thing up here, but without needing to write nearly as much code. Router component, router ID, ident, list of screens that'll work with that ident function to route among, or be switched among by this router. Little factory for that router, compose it into state, query, set up some ways to do your route tos, and then render the thing. And again, we end up with the same thing. Okay, on to slightly more advanced. So as I mentioned a minute ago, the next thing that you might want, and I can't do it in a dev card because dev cards already use HTML5 routing for moving from thing to thing. So if we actually try to use, rig on top of that within a dev card, we end up with fights between dev cards in your application. So I've embedded, or I've placed this sort of thing inside of a regular app in the same source code. And so we're going to pop over to so we're done with components. Sorry, I'm trying to remember where I put the code for the next bit. Client takes us to root. Okay, so some of this is going to look similar, and in fact we're pulling in homepage screen 2. Let's go ahead and look at report and summary. So report is just a screen that could show something with a report name, and of course the idea is there would be various tables and charts in a report. And reports are normalized by ID, and then summaries are the same sort of thing. And so we're going to pull those in along with the homepage and screen 2 we've already been seeing. And we're going to add a report router. Now the report router, the idea here is that, and you watch the URL as I go here, just so you see what I'm heading towards. I'd like to be able to have the URL, right, match the thing, and if I hit that screen by default, I'd like to load the thing and route to it on startup. So this is kind of the ultimate goal people are looking for when they do their routing. So let's talk through this. Let's just go down to root first. So in root, we're going to have the routing tree as we saw before, and we've got a more complex routing tree now. Top router is still our top router, and the top router routes now between home page screen 2 and a reports home screen. So the report home screen says reports main. So this is coming from this report home component, and then the report home component could show you various kinds of reports. So the idea there is we know we're a screen, and our screen is reports. This gets us the ident compatibility that we need for the top router, right? The first element of this ident needs to match, you know, which one of these we want to run the query for and which one of these we want to run the render for. So we need to embed that just as we did in the other two, home and alternate. And then the initial state, I'm using the shorthand notation here. If you use a map with initial state and there's a join on a keyword, it actually wraps this in prim get initial state. So this is the parameters to the initial state for the child report router. So basically, that's identical to what I had before. So if you don't wrap it in a lambda, it realizes that a join, you can't possibly just want to put an empty map there. If you do want to put an empty map there, you need to wrap it in a lambda. What you more likely want is to look at the initial state of this guy. Well, the report router looks just like the other router that we had earlier, except this time we're determining what goes in the first element of the ident by whether or not the props of the thing have a report name. If it has a report name, well, then it must be a report by ID kind of thing. And if it doesn't have a report name, well, then it's probably a summary by ID. So this is a way of deriving which kind of thing we have by the data in the props. And then, of course, the database ID can be the second thing. So now we've got a router that can route among really an arbitrary number of different screens. Two different kinds. It's either a report or summary, but there could be thousands of IDs of these things, right? Which is what you're seeing over here. I might want report 2, which is raw sales, or report 1, which is statistics, right? So, and you see I've got loading joined up with those. So, so the type is that, but obviously I'm getting different values as well. So here our ident has 2 variables. It's not just a fixed single like we had before, screen or single or what? Yeah, single is what we had before. So we're actually going to put an ID there. Create a little factory for that. Reports home now just has to compose that router in. So really very little additional complexity to get this additional report routing happening in terms of the UI, right? I just need the router. I need to say that it renders either report by ID or summary by ID. These are just the table names, which is what you expect for normalization. We can glance at report again real quick so you see the ident is report by ID and then whatever's in the DB ID of props. Report home's just a wrapper, so we could have various additional content in there. And then top router, all we did was added it in. So now we add some buttons in so we can play with this, just to see that things work. And now you're probably interested in, of course, how we get the URL to dance. So hopefully you've understood the code composition, and if I already had these reports in app state, well, then I've got no problem, right? They'll route right up. But if I don't have a report or a summary in app state, then of course I need to load. So let's look at those various components. Let's start with the routing tree. So the routing tree is now a little more complicated. We have index and alternate just like before, But report and summary are now new routes, new handlers, and notice they've got 2 router instructions each. The first routing instruction is move the top router to reports, the reports screen, so that's reports home, and that's the same in both of these. And then the second instruction in this one is move the report router to report by ID, and then whatever is in the route params as ID. So this is the dynamism that you can add into this routing tree. So same thing with summary. We're going to move the report router to a summary ID, and then whatever ID is passed in as the parameter. So you could see back here in our buttons, the nav2 function takes the name of the handler and then the parameters to plug in. And we'll get to that in a moment. Let's stay with the routing tree. Okay, so that's how you parameterize your routing tree. I've got some additional little helpers. Valid handlers is just a set of these keys, so it'll essentially turn into index, alternative, report, and summary. History is for we're using Pushy, a separate library, to deal with the HTML5 history events, and it gives us back an actual thing that Pushy generates. This isn't being used at the moment. I'm going to leave it, so ignore it. And then this bit is URL route mapping. So we're using another library called BIDI, which stands for bidirectional, I think. And I'm using the verbose method of defining what the URL can look like. So I'm starting with the root branch, and I'm saying, well, if there's nothing there, I'm on the index route. If I see index.html there, I'm on the index route. If I see alternate there, then I'm on the alternate route. Oops, if I don't see anything there, it should route me to something like the index screen. Sorry, and I don't need these for the moment. Actually, I'm going to want the REPL there because I'm about to show you what this interprets. Then I've got a branch for reports that has a parameter that's going to be placed in the parameter :ID, and then a leaf of nothing more where I use the report handler, or the report handler, the report route name basically, and then summary with a parameter of ID gets me the summary. So BIDI match route, if I run this, run a few things through the REPL here to get everything loaded up. So my route mappings, right, that just turns into a big vector of data. If I then say match route / I get handler index. If I say match route / alternate, I get handler alternate. If I say match route reports 20, I get handler report and route params of ID 20. So this is essentially how we're going to translate what we see on the URL to the correct things to pass to the underlying routing system. Invalid route just checks to see if a keyword is nil or isn't in the valid handlers list. Redirect is just a little helper function on the state map. So here's BIDI going in reverse direction. So if I ask it to redirect to a specific BIDI match, this gives me back the path that goes with that. So if I give it handler, for example, index, given these URL mappings, it'll give me back / or / index. I don't remember which it does. And then pushy set token, I do know what it does because I've got this. It takes me to / because if I do something invalid, it redirects to index. So this push token function just tells Pushy to put that path in the history on the URL. And then, of course, this returns the state map. So this looks like a mutation helper. So set route's another mutation helper. If it's an invalid route, then it redirects the state map. Right? This guy takes the state map to the handler index. So this is the if I give it something screwy, send me to the right thing just an index page. Otherwise, this is a helper function from, again, the built-in Fulcro routing library that takes a state map and a biddy match and uses the routing tree that we've embedded in app state to trigger the appropriate router changes. Okay, now in terms of loading, I've got some additional helper functions here. So if you remember back on our report home, which is in this guy, actually the report router, this guy's going to look to see if report name is on the object to put report ID in the first element. So if I were to set the router to a report that isn't there, well, then I'm going to have a problem because the ident that this is going to generate is going to be nil. It's going to give me nil. There's not going to be a DB ID. I'm going to get nil, nil. And my router's going to not show anything. I'll get errors in the console and it'll make a mess. So what I have to do to help with that is in my routing here, I've got an ensure report loaded where I can give it the environment of the mutation that's being run, the ID of the report, and all I do is basically say, if I don't find anything in state at report by ID, then I'm going to throw something in state at report ID by ID where it's just the DB ID and loading. I could also put some additional marker thing in here that would tell me, oh right, I'm working on one that isn't loaded yet. And then I'm going to run a load action, which can be run from within a mutation that adds something to the load queue for report by ID. So I'm loading by ident using this component for a query with no load marker. Same thing for ensuring the summary is loaded. Got this additional helper function, ensure integer, that just makes sure that if I'm given a string, which is what I'll get from this on the URL, this 1 will come in as a string, I can turn that into an integer. And I default it to 0 if it doesn't parse. So then this little helper function kind of composes this all together, ensure things are routable. So if I hand this a biddy match and the mutation environment, it pulls the ID out of the route params, turns it into an integer, and then if the place I'm going is a report, it ensures that that report is going to be loaded and has a placeholder. If it's a summary, same thing. So this gets me to my mutation that I'm actually using, I think, in the UI here. I'm using nav2 here, which is the next one. But anyway, this is what set route eventually is, the mutation that gets called. It takes a biddy match. It calls ensure routable, and of course that only does something if it's a report or a summary. And then runs the set route here, which will either redirect or update the routing links. So it's a lot of little steps, but they're all really simple. And then my remote side of set route always says I'm doing a remote load. Now that may not be true, but technically that's okay, because all remote load does on the remote side is ask the underlying networking system to look at the load queue and to run any load that happens to be there. If there's nothing in there, it turns into a no-op. So I could try to put logic in here to keep that from happening, but it's a waste of my time to try to keep something from running that just is a short circuit if there's nothing there. So then I've got this top level function that's going to run the transaction for me. And it's got a little escape clause here to decide which way to do it. So if I say nav2, I give it a component, a page, and optionally route params. So if we're using HTML5 writing and history has been initialized, then we're going to look up the path for that and use set token to update it in the URL instead of running the transaction directly. The reason we do this is set token triggers this set route. And actually, this is a little. Let me step down. So if we're using history, we want to use set token, which has a callback that will do this transaction. If we're not using history, then we just do the transaction ourselves. So this is the mutation we want, set route. So if we weren't using HTML5 history and we said nav2, we'd get this. This is basically a little shortcut thing that we can use to be able to embed this in a dev card and have it not play with the URL, which is why I said at the moment I'm not using this use HTML5 routing flag, but if I were, that's what it's for. So when the client application first starts, so let me go over to client. Right now I'm using a server emulator, so I can run server code in the browser, so I don't have to write separate server code. So you can ignore that. But the started callback basically calls this start routing function and hands it the application root of the reconciler, which is something this start routing function wants. And really all this function does is, as long as history has not been initialized, so the atom is empty, then it creates a set route little handler, which is basically just a transact on set route, as I said, against the biddy match. That's not needed. And notice there's a timeout here. The reason for the timeout is when we first start routing, we want to make sure that the DOM has finished mounting and such before we run the initial set route. So essentially we want to just let go of the thread. React will take over and render for however long it wants. So this could even be, 0. And then this will set the route. So we call pushy. We tell it that this little local set route lambda is how it changes the route, and then we tell it biddy match route using biddies. Remember, this route mappings is just this branch leaf mess. This is a partial application of match route. So we tell it use set route to change the route, and use this function to figure out how to, what route you're going to. And then I've supplied this additional identity function. This is a thing you can give to pushy that basically hands you what the match was and lets you modify it if you need to. And I'm just giving it a function that doesn't modify it unless it's nil. So fnil gives you back a function that when it's nil, it gives you back this. So, and I'm actually giving a handler, and I'm explicitly giving an invalid page so that my redirect will detect properly and send me back to index. So then I call start. When start gets run, it looks at the URL and immediately hits this set route transaction. So that's how the whole sequence happens. So now you can see home, alternate. Oh, why did my routing suddenly stop working? There we go. Thinking a hot code reload or something there confused it. I hadn't really tested this much with hot code reload, but you can see now the URL changes appropriately. If I go to some specific thing that's not loaded yet, it shows loading. I specifically put a 1-second delay in my mock server so that you could see it doing that. And I don't have any of these things preloaded, so the first time you hit them, you'll see loading, but then the next time you hit them, they'll already be there. So this is the basic rundown. I'll push this code to GitHub. I'm using Shadow CLJS for this particular video and little project. So the setup to get this running is slightly different. I'll show you that very quickly just so you don't have to read the docs too much. I'm running a Leiningen, so I did a plus Leiningen to make a Leiningen profile, and I'm running this run -m shadow CLJS DevTool CLI watch on main and cards. This gives me the dev build and the cards build with profile CLJS. That's important as well. And then for REPL, I've got it pinned to port 9000 on a remote. So this is a add closure REPL remote to get one of these. And this will give you an in-REPL port. And then you can look at the instructions in Shadow CLJS for properly connecting to a running build. Well, I can just show you very quickly. This is in my user namespace. I've got this require, and then this function will let you select one of your builds in the REPL. And if you're using IntelliJ, it'll start out in a CLJ mode. You'll run this, and then you can switch it to CLJS, and then you can see I've been running CLJS things in the REPL as a result. So I just basically have both those running. right, like I said, look in the description for the URL for the code, and enjoy.